Hi everyone, we're solving this math paper today. This is 9709, paper 41, Mechanics, October, November 2023. The time is 1 hour 15 minutes. All answers should be given to three significant figures or one decimal place for angles in degrees. And unless a different level of accuracy is specified for the question, and for the value of g, the acceleration of free fall, we are to use 10 meter per second square. The maximum mark is 50. So before we begin, let's take a look at the threshold. This is component 41. Out of a maximum mark of 50, a was at 38, b was at 34. Okay, a was at 38, b was at 34. So out of a maximum mark of 50, we know that a was at 38, b was at 34, c was at 26, d was at 19, and e was at 12. So looking at this, a star, the gap between c and b is too high, honestly. Like the gap here is 7, then the gap here is, how much is it, 8, gap here is 4. So yeah, a star should be at around like maybe 42 or 43. That's the mark for a star. Okay, so let's start the paper. Also, by the way guys, if you like the content, please remember to subscribe to the channel. It helps with the algorithm a lot. Also, if you require more help, you can consider supporting me on Patreon. There are three tiers: one for general support, the second tier is actually for one-on-one problem solvings over text, and you get access to all my solved papers in OneNote from 2002 to 2023 with working for physics, chemistry, and biology paper 1, 2, 4, and 5, and math P1, P3, M1, and S1. So that's a lot for $20 a month. You can cancel the subscription whenever you don't require it anymore. And also for the highest tier, you get access to all the same features plus one-on-one video meetings with me via Google Meet, where we solve your problems once or twice a month. So you can look into that if you require more help just before the exams, maybe 1 or 2 months before the exam. Anyway, without further ado, let's begin. I actually have this paper solved, so it's not going to take a lot of time. So, what do we have? A particle of mass 1.6 kg is projected with speed 20 meters per second up a line of greatest slope of a smooth plane inclined at alpha to the horizontal, where tan alpha equals to 3 by 4. So whenever I see tan alpha is equal to 3 by 4, I immediately draw this triangle over here. So since tan alpha is equal to 3 by 4, opposite is 3 and adjacent is 4. So using Pythagoras theorem, the value of hypotenuse must be 5. So as a result, we can get the ratios of sine alpha, which is opposite by hypotenuse, 3 by 5, and cos alpha as well. Now they've asked us to use an energy method, and since it's a smooth slope, there is no friction. So basically, as the object goes up, it will gain GPE, right? It gains GPE, and at the same time, it will lose KE. So since they told us to use an energy method, we have to do it this way. So the loss in KE, right? The loss in KE of the body will be equal to the gain in GP of the same body. So we know that KE is half mv square and GP is mgh, right? So half times the mass, which is 1.6 times 20 squared. That's the initial speed of the particle. That's the loss in K will be equal to the gain in GP, which is mgh. So the mass is 1.6, g is 10 according to the question paper, and h is the height that the object gains. Okay, so after you do the working, you can get rid of 1.6 on both sides. You actually end up with a height of 20 meters. Now, do you see this dotted triangle that I drew on the right hand side? We can use this to find out the distance moved, this x. Why or how? We know that alpha, we know that sine alpha is equal to opposite by hypotenuse. No, now we know that the opposite 20 meters is the height that it moves. Okay, it will come up to this point basically. So we can say that sine alpha is equal to opposite, which is 20 divided by hypotenuse, which is x. That's what I did over here. And finally, we can get that x is equal to 20 by sine alpha. And sine alpha from this triangle is actually 3 by 5. It's 3 by 5. So we actually get a value of x is equal to 100 by 3. You can keep it like that, or an alternate was you could say it's 33.3 rounded off to three significant figures. Same thing, they'll accept both. Okay, hopefully that's clear. Let's move on to question 2. So for question 2, we basically have a particle which is held in equilibrium, so net force is 0. We basically have to equate the components here, right? We equate the components. So there are two strings. One is attached to point A, the other is attached to point B. The strings make an angle of 35 and 40 degrees to the horizontal. Find the tension in each of the two strings. Okay, so basically equate the horizontal forces and the vertical forces. So I'm calling the tension in string B TB. Okay, you could also call them T1 and T2, same thing. So TB cos 40, the horizontal component, right? The horizontal component of string B, TB cos 40 is equal to TA cos 35, since there are no other horizontal forces. That's what I did over here. And on the other hand, the vertical components, the weight 2.4 g downward force is equal to the summation of the upward forces, Ta sine 35 plus Tb sine 40. That's what I did over here. Now I made Ta the subject over here as Tb cos 40 by cos 35, and we input that into this equation over here. In the place of Ta, I input Tb cos 40 by cos 45, and finally we can take TB common. We actually get TB cos 40 times tan 35, because sine 35 by cos 35 is tan 35, plus sine 40. Now if you do the working, if you use the calculator properly, you will get an answer of TB is equal to 20.4 rounded up to three signal figures. Now if you input that back into this equation over here, you are going to get a final answer of 19.0. If you input the calculator answer of TB into this box over here, you will get 19.0. So that's that for question 2. Pretty straightforward, just resolving components. Can't get easier than this. Moving on to question number 3. So this is a velocity time diagram. Find the distance covered by the bus in the first 8 seconds. So we know that the area under the velocity time graph is actually the displacement, change in displacement. So as you can see in the first 8 seconds, it's a triangle. So it's simply going to be half into base into height, which is half into 8 into 12.6. We get an answer of 50.4 meters. Now we are asked to find out the value of the acceleration, where, look at the question. It says the bus starts from rest and accelerates uniformly for 8 seconds until it reaches 12.6. The bus maintains this speed for 40 seconds. Alright. It then decelerates uniformly in two stages. Between 48 and 62 seconds, the bus decelerates at a meter per second square, and between 62 and 70 seconds, it decelerates at 2a meters per second square until coming to rest. So over here, the deceleration is a. Okay, over here the deceleration is a, and over here the deceleration is 2a. Now find the value of a. Okay, so we are gonna do it in two phases. This is the first phase and this is the second phase. So what is our initial speed over here? 12.6. And what is the final speed over here? We can call it v for now. Let's call it v. So we can simply use v is equal to u plus at. So they actually used v1 in the mark scheme. That's fine, anything works. The final speed of the first phase. So v1 is equal to the initial speed, which is 12.6, minus a times time. The time is 62 minus 48, which is 14 seconds. Okay, 62 minus 48 is 14 seconds. So is the value of v1. And then you have to remember this always. Remember this teaching, okay? The final velocity of the first phase is the initial velocity of the second phase. Now we can go for v is equal to u plus at again. V is equal to u plus at again for the second phase though. But the acceleration this time, deceleration is the acceleration is minus 2a, or the deceleration is 2a. And the final velocity is 0. So what can we write? 0 is equal to v1. The final velocity of the first phase is the initial velocity of the second phase. 0 is equal to v1 minus 2a times t. T is 70 minus 62, which is 8 seconds. So 0 is equal to v1 minus 2a times 8, which is 0 equals to v1 minus 16a. So yeah, we actually get this answer. V1 is equal to 16a. Now we have two equations, right? One of them is from the first phase, V1 is equal to 12.6 minus 14a. The other one is V1 is equal to 16a. So we can equate these two basically. Let's equate equations 1 and 2. So 16a is equal to 12.6 minus 14a, 30a is equal to 12.6. So a gives, we get a value of a which is 0.42 meter per second square. That is the thing that they wanted. That's our answer. Finally, what's part 3? Find the average speed of the bus for the whole journey. So you guys need to realize something. The formula for average speed is total distance divided by total time. Okay. So what is the total distance? So we know the distance for the first phase, which is 50.4 meters. And then for this rectangle, what's it going to be? 48 minus 8, which is 40. The time is 40 seconds. It's a rectangle, so length into breadth times 12.6, right? So 40 times 12.6. And what about this? We have another triangle here, and we also have a trapezium here. So basically, you need to find out the value of V1, which I already did over here. V1 is 16a, 16 times 0.42, which is 6.72. We know the value now. So for the trapezium, it's going to be half into a plus b into height. So half into 12.6 plus 6.72 into height, which is 14. And for this triangle, it's going to be half into 8 into 6.2, half into base into height. So if you add all of these up, you're going to get the total distance. And the total time traveled is 70 seconds. So if you divide the total distance, 716.52, divided by 70, you are going to get the average speed, which is 10.236. You could also answer it as 10.2. That is also fine. They would have accepted it, rounded off to 3SF. And also one other thing that I need to mention is, please show the working of finding out V1, right? The speed at time 62. This is the speed at time 62 seconds. The final velocity of phase 1 that I called, in this part there was 1 mark for showing this over here rather than over here. Okay, so that's that. Moving on to question number 4. How many do we have in total? I think we have 7 questions or something. Yeah, 7. We'll be done soon, like in 20 minutes. Thing is, M1 is really simple if you know how to do the sum, but if you don't, it actually takes a really long time. So two particles P and Q of masses 6 kg and 2 kg respectively lie at rest 12.5 meters apart on a rough horizontal plane. The coefficient of friction between each particle and the plane is 0.4. Particle P is projected towards Q with speed 20. Okay, so P is projected towards Q with the speed of 20. P has a mass of 6 kg and Q has a mass of 2 kg. Now show that the speed of P immediately before the collision with Q is 10 root 3. Okay, so P travels 12.5 meters, and since it's on a rough plane, as you can see, this is the wording, since it's on a rough plane, it will actually decelerate. So we need to find out the deceleration first using F is equal to ma. Since it's on horizontal ground, the reaction force is totally providing the friction, which is F equals to mu r. So that is 0.4 times 6g, which is 60, is equal to 6a. The deceleration is 4 meter per second square. So we have to use the v square equals to u square plus 2s equation. So v square is equal to 20 square initial speed square minus 2 into 4 into 12.5 meters. That gives us a value of 10 root 3. That's the velocity of P just before colliding with Q. Now in the collision, P and Q actually coalesce. What does that mean? They turn into one combined particle. They stick together. So the combined mass has now increased. Find the loss of kinetic energy due to the collision. Okay. So basically what's going to happen here is, um, the law of conservation of momentum will be followed. That means the sum of the initial momentum will be equal to the sum of the final momentum. So what's the sum of the initial momentum just before the collision? It is actually 6 kg times 10 root 3. That's the initial one. And what about the final one? It's going to be the combined masses, which is 6 plus 2, 8. 8 times v. We don't know this v. So yeah, we found that out to be 15 by 2 root 3 or 7.5 root 3. Now the initial K is only P is moving, right? So half into 6 kg, half into 6 kg times 10 root 3 whole square, which is 900, and the final one is half into the total mass 8 times 7.5 root 3 whole square, which is 675. So the loss in Ke is actually, as you can see, 900 minus 675 joules, which is 225 joules. That's the net loss in kinetic energy due to the collision. So clearly it is inelastic. Now the last part for question 4. The coefficient of friction between R and the plane is 0.4. R is the combined particle. P and Q coalesce to form a combined particle R. Okay. So now R also has a coefficient of friction of 0.4 with the floor. Find the distance traveled by particle R before coming to rest. Okay, so we need to find out the deceleration again. So the net friction will now be mu R, which is 0.4 times 8g, since they have a combined mass of 8. So 0.4 times 8g, which is 32 newtons. That's the combined friction. Now if you find out the deceleration, what will it be? F is equal to ma, so 32 is equal to um, 8 times a, the deceleration is 4, just like before, the deceleration is still 4. Now we have to find out the distance traveled before coming to rest. So we don't need time, so we can just use v square is equal to u square plus 2s. So 0 is equal to the speed right after collision, which we found over here, 7.5 root 3 whole square, minus 2 into 4 into s. We need to find this s out, then we get a distance of 21.1 meters. This is how you do the sum. Okay, is that fine? Moving on to the last 3 questions. We are currently at question number 5. So let's do this. The diagram shows a particle A of mass 1.2 kg which lies on a plane inclined at an angle of 40 degrees to the horizontal, and a particle B of mass 1.6 kg which lies on a plane inclined at 50 degrees to the horizontal. Okay, fine. The particles are connected by a light inextensible string which passes over a small smooth pulley P fixed at the top of the planes. The parts AP and BP of the string are taut. They are taut and parallel to the lines of the greatest slope. The two planes are rough with the same coefficient of friction mu between the planes, between the particles and the planes. Find the value of mu for which the system is in limiting equilibrium. Okay, so you have to test something out here initially. Okay, what do you need to test? You need to find, also by the way, you know the geometry, right? Since this is 50 degrees, this angle over here will also be 50 degrees. This is the basic of any slope sum according to geometry. Since this is 90, this is 40, and this is 90 degree, so 90 minus 40 is 50. That angle must be 50. So you need to compare something. Okay, the component down the slope, you need to see which one is greater. For B, the component down the slope is 16 sine 50, and for A, the component down the slope is 12 sine 40. Okay, so if you use the calculator, you can clearly see that 16 sine 50 is greater than 12 sine 40. So depending on the greater force, the motion will be determined. Depending on the greater force, the motion will be determined. Okay, so since the component of weight down the slope for B is greater, um, you will basically, the B will move down. B will have a tendency to move down, and A will have a tendency to go up. Why am I saying tendency rather than will go? Because the system is in limiting equilibrium. So the friction is at its maximum value and the system is about to move, but it's not moving. That's essentially the scenario right now. Okay, so since B is about to move down, right? Since B is about to move down, friction must act upwards. Friction always opposes motion. So since B is about to move down, friction acts upward, and the tension will always act away from the object. So the tension for B is also acting upwards, along the plane of the slope. Okay. Now for A, since B is about to move downward, A is about to go upwards. Okay. So A is about to go upwards. So the tension is the greatest force over here. And since A is about to go upwards, friction will act along the slope downwards. Okay. So friction plus the component of weight, which is 12 sine 40, these two combined, friction plus 12 sine 40, uh, the summation of these will actually balance the value of tension. Okay, so I'm going to break this down for you again. I compared the components of weight for A and B. I saw that the component for B was higher, number one. So I know that B is about to fall down and A is about to go up. So since B is about to fall down, the weight must be the greatest force component, 16 sine 50. But since it's in limiting equilibrium, the component of weight must be equal to the value of tension and friction. On the other hand, since A is about to go up, the value of tension must be greater. So the value of tension must be equal to the value of the component of weight and friction, which is acting downwards to oppose motion. Okay. So as you can look at the equations for B, it's 1.6 g sine 50 is equal to tension plus friction, which is mu r. And for A, it's 12 sine 40 plus mu r is equal to the upward tension. Now mu r, for R, the reaction force for B is 1.6 g cos 50, and for A, it's 1.2 g cos 40. Now, if you just input these, you actually get two equations, one of this and one for this. Now, you can actually substitute the value of tension, Suppose if I call this equation 2, you can substitute equation 2 into equation 1 in the place of t, this t over here. So 16 sine 50 is equal to mu times 16 cos 50 plus, I just input this in, the value of t from equation 2, 12 sine 40 plus 12 cos 40 times mu. Now if you break everything down, put mu on one side, you actually end up with 16 sine 50 minus 12 sine 40 equals to mu times 16 cos 50 plus 12 cos 40. So ultimately you end up with a value of mu is equal to 0.233. That is the only answer that you will get. Okay, rounded off to 3sm, of course. Hopefully you guys get this up. So moving on to the last two questions, 6 and 7. A car of mass 1300 kg is moving on a straight road. On a horizontal section of the road, the car has a constant speed of 30 meters per second and there is a constant force of 650 newtons resisting the motion. Calculate in kilowatts the power developed by the engine of the car. Okay. Since there is constant force resisting the motion and it is moving at constant speed, the forward force or driving force is equal to the resistive force. Since constant speed, net force 0. So driving force equals to resistive force, and we know that P is equal to Fv. So the driving force equals to P by V. So P by V is equal to the resistive force. P by 30 is equal to 650. So P is equal to 19,500 watts or 19.5 kilowatts. Good. Given that this power is suddenly increased by 9 kilowatts, find the instantaneous acceleration. So the new power is 19.5 plus 9, which is 28.5 kilowatts. Now, P is equal to Fv. P is equal to Fv. So we will use the new power, which is 28,500, and we are going to find out the new driving force at a speed of 30 because it is increased suddenly, right? Instantaneously. So currently our speed is still 30 from the previous scenario. That's why we can use this new power, same velocity, new driving force for the time being. Okay, now what is the new acceleration? So we have the new driving force, which is 950. Basically you pressed on the accelerator suddenly. You'll know if you drive a car, you know what happens, right? You suddenly feel the pull, or the push, I mean. So 950 minus the resistive force is still the same since they just said nothing about it. So 950 minus 650 is equal to MA 1300A. So the value of A is 0.231, 0.231. So that's that, which is 3 by 13 or 0.231, 3 by 13. Now for part B, let's check this out. On a section of the road inclined at sine inverse 0.08 to the horizontal, the resistance to the motion is 1000 plus 20 V newtons. When the speed of the car is V, the car travels downwards along this section of the road at constant speed with the engine working at this. Okay. So what are the forces acting on the vehicle? Since it's on a slope, it will obviously feel the component of weight downwards. Okay, that's one. Also, since the engine is working, it will also feel a driving force. Okay, and it is also feeling a resistive force which will be felt backwards. Okay, Now, since it's constant speed, all the forward forces must be equal to the backward forces. So what are the forward forces exactly? The driving force of the engine and the component of weight, which is mg sine theta. So the net force is 0, so mg sine theta plus the driving force is equal to the resistive force of 1000 plus 20v. Now what is the value of mg sine theta? We know that the theta is sine inverse 0.08. So what will the value of sine theta be? I can put sine backwards in this side. So sine theta is actually equal to 0.08. So sine theta equals to 0.08, because we know that the value of theta is sine inverse 0.08, right? That's what they mean by this equation, this sentence over here. So sine theta equals to 0.08. So mg 1300 times 10 times 0.08 plus the driving force. We know that P is equal to Fv, so driving force equals to P by V. Now the power is 11,500, right? And the velocity is V unknown. And the resistive force is 1000 plus 20V as mentioned in the question. So we are to find this constant speed. So after working, you actually end up with this, you know, 1300 uh, 11,500 by V minus 20V. I put the 20V on the left hand side is equal to 1000 minus 1300 times 0.8. I multiplied 10 and 0.08 over here. And then we end up with, if we do the LCM, 11,500 minus 20V square by V is equal to 1000 minus 1300 into 0.8. Okay, so after cross multiplication, you actually get a value of minus 40 over here. I cross multiplied the v to the right hand side, so 11,500 minus 20v square equals to minus 40v. And if you solve the quadratic equation, you actually end up with this 20v square minus 40v minus 11,500 equals to 0. So you don't need to show the working for the quadratic equation. You can directly just write, you can input it in the calculator and you can get a value of v is equal to 25. So that's the equation. You can simplify this a bit further. You can write it as 2v square minus 4v minus 1150 equals to 0, but it doesn't matter. You can just find out the answer directly. They basically want to see your attempt at Newton's second law, and see if you've come to this equation over here. Okay, the net force must be 0. Moving on to the last question for the day. Question number 7, motion in a straight line. A particle moves in a straight line starting from point O before coming to instantaneous rest at point X. At time t seconds after leaving O, the velocity of the particle is given by this equation, where k is a constant. It is given that there is no instantaneous change in velocity at t8. What does that mean? You know that there are 3 phases. The second phase is from 2 to 8, and the third phase is from 8 onwards. So look, phase 2 and phase 3 has a common point, which is t8. So since there is no instantaneous change in velocity, that means the final velocity of the second phase will be equal to the initial velocity of the third phase. That's what it means. Okay, so we're going to exploit that fact. I'm going to input t8 over here in the second phase equation. I get a value of 23.4 meters per second. Now I can also input t8 over here. So I actually get 1600 by 8 square, which is 1600 by 64 plus 8k. Now the value of the velocity at the end of the second phase, 23.4, will actually be equal to the value of velocity, right? The initial velocity of the third phase, which is this 1600 by 64 plus 8k, is equal to 23.4. And after you solve this equation, you get a value of k is equal to minus 0.2. We need this for the future. Since this is a 9-mark question, it's huge, right? Whenever you see a text like info like this, right? Something like this, you have to do this. Like whenever they say that there is no instantaneous change in velocity, always apply the technique that I just did over here. Okay, remember, it will always work. Okay, now what are we asked to find? The distance OX. So it comes to rest at a point X, okay. So to find out distance, we have to integrate velocity to find out, displacement. So, but before that, we need to know where it comes to rest, when actually. So you can actually input v0. to find out when it comes to rest, we have to try each equation individually. So for example, I try with equation number 1. Okay, I try with equation number 1. I try to input v0. I actually didn't try with equation 1 because look, if you tried with equation 1, v is equal to 7.2 t square. So 0 is equal to 7.2 t square. So t is equal to 0. So it starts from rest. This isn't giving us any info. In the second one, you can try 0 is equal to 30.6 minus 0.9 t. 0.9 t is equal to 30.6. Let me try this one out. Give me 1 second. 30.6 by 0.9. 34. T is equal to 34. This doesn't make sense because the second one is only valid from 2 to 8. Okay, that's why this is not valid. So the only possibility is it will come to rest in the third phase, which is t is greater than or equal to 8. That's why I input v equals to 0 in the third phase, and after you solve the equation you get a value of t is equal to 20 seconds. So at 20 seconds my particle comes to rest. But now since you have three individual or different equations for the three phases, you have to find out the distance separately. Okay, step by step. So for the first one, if you integrate it, you get 7.2 t cubed by 3. You apply limits of 2, 0. So you get an answer of 19.2 meters. The second one, if you integrate it, you get 30.6 t minus 0.9 t square by 2. And you apply the limits of 8 and 2, 8 and 2. Okay. So you also get the distance for the second phase. As you can see, I've done the working over here, 156.6 meters. And finally, for the last phase, you integrate this, which is 1600 t to the power minus 1 divided by minus 1 and minus 0.2 t square by 2, right? That's the integration for this. 1600 t to the power minus 1 by minus 1. The power act was initially minus 2, right? So it's minus 1 by minus 1 minus 0.2 t square by 2, which is 0.1 t square. And the limits are important. The start will be 8, but the end will be 20 seconds because that's when our particle stops moving. So the limits are 20 and 8. If you solve this properly, you get an answer of 86.4. Now if you add all of these up, 19.2, 156.6 and 86.4, you're going to get your final answer of 262.2 meters. Okay, so that is the total distance moved. And since it does not stop midway anywhere, we don't have to do any separate things because we know that the only point it stops is at t20. There are some questions where you need to separate the individual phases into more parts, but that's a question for another day. Okay, so I hope that helped you guys. That was it. A relatively easy paper in my opinion. um, I'll upload papers 4.2 and 4.3 for the October November 2023 session soon as well. Quick shout out to my top tier patrons for the month. For this month, we have Dewa as usual and a new patron, Prabha. So if you guys want to be featured at the end screen as well for all of my videos, as well as get access to question paper requests with high priority, please do consider supporting me on Patreon on the highest tier. And that has been it for the day. If I made any mistakes or if you have any other queries, please do comment below. I will link the paper for um, October November 2023 paper for 2 up here when I solve that, and the paper for October November 2023 paper for 3 down here, and the playlist for M1 up here. Remember to hit the subscribe button. See you guys. Bye bye.